All right, just going over a few more examples of rationalizing the denominator on number 4. Even though there's a radical in the numerator, it kind of doesn't matter as far as what you multiply by. This is the radical that's in the denominator, the square root of 2. So I want to multiply both the numerator and denominator by the square root of 2. Now in the numerator, the 5 is underneath the square root, so is the 2. So I can multiply those together. It'd be the square root of 5 times 2 or the square root of 10. You actually won't be able to simplify that. And in the denominator, I can multiply these 2's together, square root of 4, which is just 2. And that's all you can do. Don't try to simplify the 10 over 2. Again, this is underneath the radical. This is not. On number 5, again, what's most important is the radical in the denominator, which is the square root of 5x. So I multiply both the numerator and denominator by the square root of 5x. Whatever you multiply the numerator by, you have to multiply the denominator by as well. It's kind of like an equation where whatever you do to one side, you have to do to the other. Right now in the numerator, this number is outside the radical. The 5x is underneath the radical. So here's all you can do. 3 square root of 5x. And then for the denominator, square root of 5x times the square root of 5x. It would look like this. Square root of 5x times 5x. So in the numerator, we still have 3 square root of 5x. And in the denominator, we can multiply the 5's together. 25, we can multiply the x's together, x squared. And then we could simplify what's in the denominator. The square root of 25 is 5. The square root of x squared is just x. And this is simplified. The radical is out of the denominator. Okay, on number 6, here's where you need to be careful. I can't just multiply the numerator and denominator by the square root of 3. Even though the square root of 3 is the only radical part in the denominator, it's 2 plus the square root of 3. So we need to multiply by what's called the conjugate. So multiply the numerator and denominator by, instead of 2 plus the square root of 3, it's 2 minus the square root of 3. So we multiply the numerator and denominator by 2 minus the square root of 3. Technically, we distribute the 1 to both the 2 and negative 3. 1 times 2 is 2. 1 times negative square root of 3 is negative square root of 3. And in the denominator, here's what we have to do. We actually have to use FOIL for these radical expressions. Here's first the FOIL. 2 times 2 is 4. Outside of FOIL, 2 times negative square root 3 is negative 2 square root 3. This is inside of FOIL. Square root of 3 times 2. It's positive 2 square root 3. And then last of FOIL is positive square root 3 times negative square root 3. Which is negative square root 9. These two terms, here's what's always going to happen if you multiply by what's called the conjugate. The conjugate is just switching the sign in between the two parts of the term. But the outside and inside terms will always cancel each other out. The square root of 9 here is 3. So really, if you see like the complete mess that I have in the denominator, but what's still there is 4 and then minus 3. So 4 minus 3 is 1. 2 minus the square root of 3 is what's in the numerator, and then in the denominator, 1. So really, I could just write it as 2 minus the square root of 3. But anytime you have some sort of expression with the radical and the denominator, multiply by the conjugate. If I had something like 5 minus 2 square root 4, sorry, actually I'm going to make it 2 square root 7. Because if it were the square root of 4, I'd be able to simplify that. The conjugate of this is just 5 plus 2 square root 7. All you're doing is changing the sign in between them, and then you would have to FOIL things out. But like I mentioned, after you FOIL things out, the outside and inside terms of FOIL will always cancel each other out if you're multiplying by the conjugate.